Hey everyone. In the last video, we talked about what is a design requirement and when does a design requirement arise for an aircraft. In this video, we'll talk about how does one design the design requirement and what really goes into the design requirement itself. All right. So usually the design requirement, as I said, is written by customers or stakeholders, right? And often, and again, we talked about RFP in the last video, the RFP will start with few paragraphs that establishes the need for the new aircraft system. That is usually the result of customers' market analysis that defines a particular niche that the aircraft system will fulfill. And this is very important because, again, the reason why I highlighted this in red, because this is basically set context for a historical buildup. As I said, there's no way for us to know what the niche is in the market. Say if you want to design a fighter, well, you look at all the existing fighter aircraft, right? And we have to look at some of the performance metrics. We had to look at some of the geometry, and we got to look at some of its missions, right? Because we wanted to design something that it doesn't exist, all right? And we don't want to recreate an aircraft which is already in the market and already successful, right? That's not a valuable process. What adds value is for you to identify a niche, identify some gaps in the existing designs that you can actually fulfill. All right. That's one of the important reasons why we do the historical buildup, because as most companies have a very thorough database of the existing aircraft, which we don't have. So we cannot just jump into the design process without doing this market analysis, without identifying the niche or the gaps in the existing systems, right? That's one of the reasons why we need to do the historical buildup. So again, this kind of cartoon here schematic shows that customers or stakeholders are the ones who does market analysis, who do customer behavior, and who do competition analysis. As you know, right, when Airbus comes out with an aircraft, well, Boeing comes out with a competitor aircraft soon, so that they can stay in business, right? And the risk assessment, obviously, right? They don't want to invest on something that is potentially highly riskier, right? But you have to know that some requirements are fixed, which even the stakeholders and customers cannot change. Now, for example, the regulatory issues, environmental disposal certification standards, and usually from the government, right? So it's very important that as you design the aircraft, you have to look at what are all the requirements or the regulatory issues that are imposed on an aircraft of particular class and category by government, either from FAA or from military. If you don't account for that, then chances are your design is never going to go anywhere other than just a paper or in the simulator, right? So even though that may work for our purposes, uh, most important, more often than not, you really have to worry about what are all the rules and regulations imposed by the government and policies on the design that you're actually creating, right? Again, there's not even customers or stakeholders can change this. Everybody has to abide by these rules, all right? So when you're designing the airplane, make sure to check out the FAA rules and regulations so that your aircraft that you're designing meets uh, the needs, meets the requirements of those that is stated in those policies. Right. And but some requirements can be derived based on end user stakeholder needs, which we will talk about right now. It's basically deriving some performance metrics based on what the customers or stakeholders actually needs, right? And as I said, requirements can also make use of emerging technologies from industries. Most likely, like if somebody comes up with a ultra efficient engines like GE, that can definitely be included in the design process, uh, right? If you have a extremely lightweight material that people are using nowadays, like composite structures, that you almost certainly can bring that into the design requirement as well, right? So it's about like you got to look at the holistic picture here, right? And these are all some of the very important things to care about while you're designing the design requirement. All right. So I wanted to walk you through the steps in defining requirements because right, while you're setting requirements for the aircraft you're designing, you can simply follow the steps outlined in here. Right. So step one, well, you got to define the functional requirements. In other words, you got to define the concept of operation, otherwise known as ConOps, or the mission of profile. Basically, what this is you have to answer this question: what do you want the airplane to do in the most specific sense, right? For example, here is a mission profile for a Hurricane Tracker UAV, right? So the Hurricane UAV, Tracker UAV, like takes off from a runway, right? That's again important. You want the aircraft to take off from runway, or if you want to take off like in midair, again, that's something that you have to set. Right. And then, it needs to climb to a certain altitude. Then it needs to cruise or transit to the area of interest where you have some weather phenomenon, right? You need to orbit in that phenomenon, orbit over the area, and make sure that your turn radius and your sync rate is all like properly set so that you can observe what you need to observe, right? And then you need some like the tracking system. You got to come back, you do some deployment. If you want to drop some expendables, right, you can do that. And then you descend and basically land. So this is just an example of what the airplane must do, right? This Hurricane Tracker UAV, right? These are all basically basically answer the questions being like, what do you want the airplane to do? So similarly, you have to set a functional requirement for your aircraft, right? Um, Step two is technical/design requirements. You already talked about what you want the airplane to do, but here in this step, you want to talk about how you would want the airplane to do the mission, right? In other words, if we take this mission profile, well, start with runway dimension. What would be the runway that you're targeting for takeoff and landing, right? Do you want a short field takeoff or a vertical takeoff, right? That's something you need to specify. And you also want to specify when the aircraft is climbing, what is your required climb rate? What do you want the climb rate to be? What you want the climb altitude to be? What do you want the structure stress to be while climbing? Right? While cruising, you have to think about, what do you want the cruise speed to be? What do you want the cruise altitude to be? And how much range you're expecting to get out of the design of the aircraft. And during this orbit over area, you have to calculate your endurance, because endurance is nothing but like how much fuel you're burning for the required thrust that you're producing, right? So you really have to think about all of this and set some requirements so that your design can achieve those, right? Like, for example, time on station, endurance altitude, endurance speed, latitude, range, rate of sink, etc. Right. And then, if you're tracking some weather phenomenon, you got to make sure to identify the tracking speed. Or, if it is a surveillance drone, if you're tracking something on the ground, a vehicle, or some sort of moving target, you have to set the required tracking speed so that you can track at a certain altitude, right? And, if you're doing this lighter or orbit over area, you're doing a lot of turns, you're doing a lot of altitude change and all that. So you have to think about the max turn rate, how tight you want the aircraft to turn to observe a certain phenomenon. And while you're dropping packages, you have to think about what would be the drop speed and drop altitude, because while you can't drop something at any speed and any altitude you want, because well, chances are your package may not reach the ground in one piece, right? So that's something you have to require and set, and more importantly, identify, right? And also, like, you have to set the required descent rate and landing speed, how quickly you want the aircraft to come down and land in case of an emergency and things like that. So, this is something that you have to set. And you may think about all of this and say if you want to design an aircraft, well, how on earth are going to find the data, or or the knowledge database to make a informed decision on these requirements, right? There's no way. And again, at the end of the day, we don't know what we don't know, correct? So that's one of the reasons why we need to look at, um, you know, properties, and we need to look at the specifications for 10 different aircraft of in the similar category and class, so that we can make an informed decision on what is a reasonable climb rate, what is a reasonable cruise speed, time on station, drop speed, drop out, descent rate, and all of that based on like what is already existing. And doing so, we can identify the gap where you can fill the need. For example, you may notice that for a given takeoff weight for your aircraft, well, there's a gap in some cruise speed. You have like, a lower cruise speed, you have a higher cruise speed. You may not find any aircraft in that middle cruise speed. But you also have to think about is cruise speed is an important variable for you or not, right? It could be the climb rate. You want to achieve the altitude as high as possible. There is some value in that, right? That's something that you have to set, right? And there's no way for us to do this without doing a thorough historical buildup, right? So again, this is why we need to do the historical buildup, right? And doing so, again, it prevents us from designing an airplane which already exists and is already in the market. Again, we should stay away from designing an airplane which already exists, because then there's no value, there's no point, right? And also by plotting the different trends you see in the historical buildup, like in assignment, we can identify the gaps and niche, in the technical mission requirements, so that you can define, you can set the requirements based on based on the niche to achieve that to close that gap, right? So the step three, system level requirements, is basically identifying all the systems that you need. Again, not want in aerospace. It's most often the need and not the want in the airplane to perform relevant functions and complete the mission successfully, right? And the system level requirements is basically example like airframe, propulsion, fuel, avionics, communication, payload, etc. For example, if you have this UAV, right? I mean, there's a lot of systems that goes into the successful operation, successful completion of mission. For example, like payload system, power system, propulsion system, airframe, navigation system. And not only that, you need a satellite system for tracking. You need a ground control system as well, right? So there's you need to think about the systems that you need in the airplane, because those systems have their own weight. So the weight should be allocated based on the systems that you have on the aircraft, right? And again, more importantly, you need the aircraft to be able to complete the mission, right? And you need to think about the systems you need to do that. And the last step is assessing the design criteria. So you got to think about what is important to you as a stakeholder or the customer. Think about, and rank stability, ergonomics, maintenance, aesthetics, safety, etc. Right? So these are all the things that you need to be thinking about, and in a year at rank, what is more important to you, and make a decision based on that, right? Just a quick example. Here is a picture of Marine One. It's an old Marine One. Marine One is the most photographed helicopter in the world, right? And now the new helicopter needs to carry the same image. So any replacement for the helicopter needs to look presidential, right? That is one of the top most design priority or criteria for this case right here. Okay, so well, this will inform your decision, because now you have to decide based on this criteria what your nose of the helicopter is going to look like, what's your tail is going to look like, which is more aesthetic, right? And actually select based on that. And keep in mind, all of this is going to inform your performance of the aircraft as well, right? So it's a balance, right? If this is important, then you make this a priority, then maybe you may have to sacrifice some performance metrics on that, right? Again, design is always a sacrifice and a compromise, right? And then you got to decide what color, what the paint job's going to be, and what kind of insignia you may want to use on the aircraft. So things like that. And this is just an example. So similarly, think about when you're designing the aircraft, what it is that you want the most, what is more important to you, right? You need to make your decision based on that. So here's a summary, right? Well, step one, you define the function requirements. What do you want the airplane to do? Step two is the design requirements. How would you want the airplane to do it? Step three is system requirements. So what system do you need to complete the mission? And step four is the design criteria. What is more important to you, to the customer slash like stakeholders? So when you're identifying the requirements for your aircraft, just basically follow these three steps. And in order for you to even start doing the requirements, well, first thing we need to do is do a historical buildup, because without doing historical buildup, we cannot identify the requirements, that 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 basically that we need, right? Because you exactly want to have you want to have an exact idea of what you want the airplane to do and how you would want to do it. All right. So hopefully all of this sets context for historical buildup assignment. In the next video, I'll be talking about what you should be doing and the type of specs you should be collecting for the historical data. All right. See you in the next video.